Well, hi, welcome to my latest video. Well, in this one, I'm going to build a little electronics project. Well, more electricity, but a little bit of electronics involved in it. I want to monitor the 3 circuits that recently got added to my den area related to a sub-panel that I had put in to give me 3 more circuits. The 3 circuits involve my 2 workstations that are down in my den, including my editing machine and my VM machine. You've seen those built on this channel before. And the third one is one that I then ran, since this is right above the den, this room, I ran up to this studio here that's for my workbench that's sitting over there. So there's 3 new 20 amp circuits that I've added. Now they came off of this dryer circuit that was a 40 amp dryer circuit that I no longer need, that was run into that same area. I'm repurposing that in order to provide these extra 3 circuits. It could actually go a 4th one if I wanted to and be able to handle the current capability of that. With that, I purchased these little devices. There's 3 of them that will allow me to monitor the power that's going through those lines. The monitoring will include the voltage level, the actual voltage value, the current value. That's going to be dynamic as depending on what I have turned on and how heavily I'm using it, and the Hertz value. Now I don't need all 3 of those, especially the Hertz. You know, that's not going to change too much to affect what I'm doing. But these were on sale, so I was able to get 3 of them for a good price. You'll see, if you're interested, the links down below in the notes to this video, the link that I used in order to order it. However, with that, I did not have a way of easily getting it into the panel. Now I did consider taking the panel out of service and maybe drilling holes into it, but it's not a big panel. It's only a substation panel. So a sub panel that is. So in order to do that, it would have been quite onerous. So I figured I would add an electrical box along the side of the panel and connect it into the panel that would then support that. That's something you're not going to find. So what I decided to do was make it using my 3D printer. And here we go. This is the bottom half of it, and this is the top half of it. I also, with the 3D printer, put in labels. They're raised labels using a different color filament to tell me which of the 3 circuits they are. So each of these little monitors will actually be going through here and showing me the values for each circuit. Now this is going to take some considerable wiring within this box in order to work properly. I have to make sure that I have those 3 wired properly, and each one of them has a pickup. So through this little side hole that I 3D printed into it, it's going to feed a cable that is measurement. It's not needed for the voltage or the Hertz measurement because these devices have to be connected to the particular circuit themselves in terms of the actual 120, 60 Hertz line. That's where they'll get their power from in order to generate the little LED displays that'll show up on here, okay? But the pickup is the only way you're going to be able to get the current. So here is an example of one of the lines that, the breaker that is for one of the lines. And what I'll have to do is we'll have to install this pickup on the outgoing hot line of each breaker. So we're going to have to remove the cable from the breaker, feed it through this little pickup, and then connect it up again. This is just going to be sensing the amount of current that's going through. Now this is utilizing a couple of standard electrical laws that are out there. One is called the Ampere law, which is the law that tells you how current carrying wires can generate magnetic fields. So that black hot wire connected up to the breaker will be generating an electrical field, a magnetic field, excuse me. It will then take that and convert it into electricity. So if you look at it, that is followed by Faraday's law, another law in the electrical concepts. And that tells you that when you have magnetic fields, they can generate current. So the current's going to be generated in these little pickups and sent to the little devices, okay? So between those 2 laws, which people will learn, most people, if they're studying electrical engineering, they'll learn that in maybe their first semester of college. Some people are fortunate enough to actually have those types of courses in one of the last 2 years or both of them in high school, like I did. So that gives a little bit of a head start. Those are interesting things to follow, and that's what this is based upon. In addition, that's also how this tool is based. This is one for measuring current. It has a little claw on it, and it's basically the same thing as these pickups. So when it closes up, it actually has a circular field that can pick up the magnetic field from the wire passing through it and generate enough of a level of voltage that can be measured and converted to current on this meter. So I don't want to have to go and check, open up the box every time and check current that way. This way I'll have constant monitoring. Now, one other thing that I decided to do in doing this project is I don't want them on all the time. So what I did is I bought myself a switch that can handle actually 4 circuits, just in case I decide to go with the 4th circuit. A 4th circuit being one that would probably measure my current going to my network server and my network rack actually. If I did that, then 4 circuits would be involved. For now, I'll just be using 3 of them when I set this up for this video. But in this case, we have a little hole that I 3D printed into this little box, and this switch will pop through the hole, and I can turn it on and off. And that basically will turn off these devices. It won't affect the circuit themselves, so that what the circuits are feeding will still be fine. And I'll show you that as we go through it. Matter of fact, I'm going to go through a diagram right now and show you exactly how that'll work, okay? Okay, let's see in a semi-high-level diagram what this is going to do once we put it into action. So here, the first thing we have is the breaker for one particular line. I'm only going to do one line out of the 3. I'm not going to do all 3. That breaker happens to be a 20 amp breaker. And then here's the sensor. We only need one of them, although remember, it's done 3 times over, one for each of the 3 lines. And then we have an outlet. And in this case, let's say the outlet's the one that's connected in my studio. So there are 3 separate outlets as well in different parts of the house. Now, we need a common bar. Now, this is something that is in the subpanel in order to connect all commons together. And in order to do that, each of the devices will need to be connected over to it. They're isolated by these little green insulators, so they're not going to be connected to the main ground that the box is on. So we connect the first common wire from the breaker over to the little strip. A second one will be connected from the strip over to the device. That is the common for the device. And the third one will be the common for the outlet, the white wire generally. All 3 of these happen to be, or at least we're going to make sure that that's the case here. Now, they won't work because there's no actual hot coming in, the black wires. So let's put the first one of those. It's going to go from the breaker. It'll go pass through the little donut that'll be able to measure its current and send it over to the sensor, and then ultimately over to the outlet. We wouldn't see a display at this point because the device itself does not have hot coming to it. The little pickup only provides a sensed amperage, and that's not going to drive that device. We need power going to that. So we've added in an extra one that's tied in with this little red twist lock, standard electrical connection, and the switch then will allow us to turn power on and off the sensor whenever we want. Now, to complete the circuit, we're going to need grounding wire going over to the main panel. So this is actually in the subpanel itself, but it'll take its ground and make it to the outlet as well, which is required by code, so that's going to happen. Now, the only issue with this is it's measuring only part of the current being drawn from the breaker. It's connecting to the hot wire prior to the donut. So the current that's going through from the switch over to the breaker is not going to be measured the way we may want it. I'm not sure how I'll do it yet. It'll only be the current being drawn by the outlet. That's the only thing that we'll see here. If we wanted to measure the minute amount of current that's being drawn by the device in milliamps, then we could do it differently. We could put the actual switch on the other side of the donut, which is what we'll show with this diagram. All we did is move the connection point of the switch so that it's on the outside of the donut, and thereby all current, including the current being drawn by the device itself, will actually be measured. Because this donut's now measuring all current that's coming out of the breaker, including the current that's being fed to the device. So anyway, that's how it would work.